Hi everyone, we're going to be doing example 3A from our notes from section 9.4, perimeter and area in the coordinate plane. The examples for 3A and 3B are a little bit different than the ones above, examples 2A and 2B. If you read the directions carefully, it's asking us to find the area of the polygon, so it's simply an area question. But there's a big hint here. If we end up with a shape that doesn't have some nice, convenient formula for it, there's a different strategy, and we're going to try that in just a moment here. First, let's go ahead and plot the 4 points carefully with labels. Got W at 1, 4, X at 4, 2, Y at 2, negative 3, and finally Z at negative 4, 0. If you connect those points, you're going to notice that this is some sort of shape. I mean, you just don't have a name for this. It doesn't look like there are any parallel sides. The lengths all look different. So this is basically just random four-sided quadrilateral. And there is no formula for that. So the strategy that we can do is we can go ahead and put a rectangle around this shape. So I'm going to start at Z and go ahead and using kind of that stair-step method, I'm going to create a rectangle that encompasses this shape. Okay. Now you'll see that after doing that, I have 4 right triangles in the corners. And just to stay organized, I'm going to go ahead and label those triangles. I'm going to call this one in the top left triangle 1, then 2, 3, and 4. Now remember, the original goal of this question is to simply find the area of this blue shaded random shape that doesn't have a formula for it. Now, let's think about this. If we simply took the area of the entire rectangle, which is something we know how to do, and then we removed or subtracted each of those triangles on the corners, we would be left with this random shape that's shaded in, which is what we want. So in essence, what we're going to be doing is we're going to try to do the large rectangle minus all 4 of the triangles. That's our goal. So let's start with what we know. This rectangle, we can find the measurements for each side just simply by counting, since it's both vertical and horizontal. 5, 6, 7. That means this side is also 7. And now along the top, 1, 2, 3, 4, 5, 6, 7, 8. Which means this side down here is also 8. Okay. That means I could get the area of my rectangle, and you'll notice how I'm keeping my work organized by using those shapes. Rectangle is base times height, so 8 times 7, which is 56 units squared. Now we need to tackle those triangles. These are right triangles, and the area of a triangle is base times height divided by 2. So since they're right triangles, they're actually not that bad. So I'm going to go through one by one, and I'm going to write in the coordinates of each of those triangles, and we can simply do this by counting. 1, 2, 3, 4. 1, 2, 3, 4. Now for triangle 2, 1, 2, 3, 4, and 5. Come on, Mr. Rentz. That's 5. So if you could please make that change. 1, 2, 3. 1, 2. And then for a triangle 3, 1, 2, 3, 4, 5 by 1, 2. And finally triangle 4, 1, 2, 3, 4, 5, 6 by 1, 2, 3. Okay, so I have those orange coordinates for each of the triangles. I'm going to take them one by one and find the area of each. So triangle 1. Again, you'll notice how I'm organizing my work carefully. Area of a triangle, as a reminder, is base times height divided by 2, or I know that some students prefer to view it as 1/2 times base times height. You can use either method. We're going to get to the same place no matter what. So triangle 1. My measurements are 4 and 5. So the area will be 4 times 5 divided by 2. This results in 20 divided by 2, which is 10. Triangle 2 has measurements of 3 and 2. So this one will be 3 times 2 divided by 2, which shakes out to 6 divided by 2, which equals 3. For triangle 3, it has measurements of 5 and 2. So 5 times 2 over 2, which is 10 divided by 2, which equals 5. And finally, triangle 4, which has measurements of 6 by 3. So 6 times 3 over 2, which is 18 over 2, which equals 9. Now, returning to this concept, if we were to just simply remove, it's almost like cutting these out. So triangle 1, gone. Triangle 2, gone. Gone, and gone. If we removed all of those from our area of the rectangle, we would be left with the blue shape, which is what we want. So we're ultimately, once again, going to be doing the area of the rectangle minus the area of the 4 triangles all added up together. The area of my 4 triangles, if I add these 4 values up, 10 plus 3 is 13, plus 5 more is 18, plus 9 more is 27. So our final area of our random 4-sided polygon is going to be the 56 units of the rectangle minus the 27 total units of the triangles, which results in 29 units squared. Woohoo!